Hello everyone. Today, these students of Mechanical Engineering third year at Delhi Technological University are going to present our project on fluid systems. And the members are Vineet Tawar, Vipul Sharma, Vishal Bhardwaj, Vishal Tyagi, Vishesh Kundu, and Priyanka Verma. The first topic is as follows.
Hydraulic circuits. A hydraulic circuit is a system comprising an interconnected set of discrete components that transfer liquid. The purpose of the system may be a control where fluid flows as in a network of tubes of coolant in a thermodynamic system, or to control fluid pressure as in a hydraulic amplifier.
Components of hydraulic circuits. There are seven components: hydraulic pump, filter, pressure relief valve, check valve, hydraulic receiver, tank, direction control valve, hydraulic cylinder.
Hydraulic pump. Oil is pumped from the hydraulic reservoir into the system. A fixed displacement pump is the simplest type and has a fixed output for the evolution of the input shaft. Modifications to this symbol describe the variable displacement pump. Filter. Filters clean oil entering the system and are used in various places within a system. Return filters are common and filter oil returning to the reservoir.
Pressure relief valve. Relief valve or pressure relief valve (PRV) is a type of safety valve used to control or limit the pressure. Pressure relief valve or PRV passes fluid from an area of high pressure to low pressure, typically the tank. Direction control valve. Hydraulic fluid flow is controlled by direction control valve. Commonly consists of four parts: valve body, spool, actuator, and springs. The spool is moved with respect to valve body. This opens and closes internal flow galleries to control fluid.
Closed loop hydraulic circuit. Closed loop hydraulic systems are also commonly known as hydrostatic drives and is a system commonly found on mobile machines such as skid steer loaders and dozers, and on industrial machines such as conveyors. In hydraulic In a hydrostatic drive, fluid flows directly from a piston pump to the motor and returns directly to the pump without entering a reservoir. The speed and direction of the fluid controls the motor, and since this is simply closed loop, the systems can operate in either direction just as easily.
Open loop hydraulic circuit. In an open loop hydraulic system, the pump inlet and actuator return ports are connected to a fluid receiver. Unlike a closed loop circuit, in this type of system, the pump provides continuous fluid flow to the system. The fluid flow through the system and returns to receiver, where upon fresh fluid is drawn from the receiver and is pumped back into the system.
Now, the second topic is control valve.
Control valve. Control valve is a valve that opens and closes fully or partially in response to signals from controllers that compare a set point to a process variable whose value is provided by sensors that track changes in such conditions. Control valves are used to control the condition of fluid flow, such as flow pressure, temperature, and liquid level. The final control element is the another name of control valve. Next slide. Operation of a control valve. Electrical, hydraulic, and pneumatic actuators often open or closes the control valve automatically. Postners are used to regulate the actuators opening or closing in response to electric or pneumatic impulses. These signals, which were previously based on 3 to 5 psi, that is zero point 0.2 to 1 bar pressure, are now typically used in industry as a 4 to 20 MA signals. The most common final control element in the process control industries in the control valve. The contract uh, to contract the load disturbance and maintain the regulated process variable as close to the desired set point as feasible. The control valve alters alters the flowing fluid such as gas, steam, water, and chemical compound. Any control loop use any control loop. Next slide. Any control loop usually consists of a sensor of the process condition, a transmitter, acknowledgers that compares the process variable received from the transmitter with the set points, that is the desired process condition. The controller in turn send a corrective signal to the final control element, the last part of the loop and the muscle of the process control system.
Control action of the control valve. Taking the example of an operated valve, there are two control action possibles. Air to open. The restriction decreases with increased control signal value. And the second one is air to close. The in this air to close, the flow restriction increases with increased control signal value. Next slide. Now, for example, air or control signal failure to close on failure of compressed air to the actuator, the the valve closes under spring pressure or by backup power. Air or control signal failure to open. In this, on failure of compressed air to actuator, the valve opens under spring pressure or by backup power. Next slide. Valve positioners. The fundamental function of positioner is to deliver pressurized air to the valve actuator such that the position of the valve stem or shaft corresponds to the set point from the control system. The positioners are typically used when a valve requires throttling action. A positioner requires position feedback from the valve shaft and delivers pneumatic pressure to the actuator to open and close the valve. The positioner must be mounted on or near the control valve assembly.
Now the last topic is pneumatic power. So introduction. So in today's world, we know that the world is shifting towards sustainable development, towards renewable sources of energy and power. Here, pneumatic technology comes into picture because it deals with the study of behavior and applications of compressed air in our daily life in general and manufacturing automation in particular. The pneumatic system uses air or any inert gases as fuel to power machinery. Now, first we need to know what is a pneumatic system because a pneumatic system when combines produces pneumatic power. Firstly, there is a compressor which reduces the volume of the fluid or the air, which ultimately leads to increase in pressure, which is stored in a high pressure tank. Then it is released to do work by acting on a piston. And finally, the gas acts as a fluid and is compressed, which creates pneumatic energy. In this diagram, we can see that we can see different components of the pneumatic power generation system, and the working principle is simple. Firstly, the air enters from this section, and due to the filter, all the dirt is removed. Then it is gone into this compressor. The compressor compresses the air by reducing the volume, which ultimately uh, increases the pressure and also increases the temperature as well. To decrease the temperature, here a cooler is used, and since the fluid is passed through the cooler, since the temperature is decreased, so due to condensation, a separator is here connected where the moisture is separated from the fluid. Ultimately, the pressurized fluid is received here in the receiver, and through secondary air treatment, it is moved to control valve, and finally the actuator which gives the power. These are the important components discussed. Air filters, as I discussed. The dryer is used to water vapor or moisture in the gas is separated from there by using the air dryer. The electric motor transforms electrical energy into mechanical energy, which is used to drive the compressor. and the actuator in the end, which air cylinders or motors are used to obtain the required movements of mechanical elements of pneumatic system. Next is the advantages.
So, what are the advantages of pneumatic system? Pneumatic control system are widely used in our society, especially in the industry sectors for driving of automatic machines. Pneumatic power have a lot of advantages. The first one is high high effectiveness. Many factories have equipped their production lines with compressed air supplies and movable compressors. Uh, there is an unlimited supply of air in our atmosphere to produce the compressed air. Moreover, the use of compressed air is not restricted by distance as it can easily be transported through pipes. The second one is high durability and reliability. Pneumatic components are extremely durable and cannot be damaged easily. Compared to electromotive components, pneumatic components are more durable and reliable. The third one is simple design. The design of pneumatic components are relatively simple. They are thus more suitable for use in simple automatic control systems. The fourth one is uh, high adaptability to harsh environment. Uh, Compared to the other systems, compressed air is less affected by high temperature, dust, corrosion, etc. The fifth one is safety. Uh, Pneumatic systems are safer than electromotive systems because they can work in inflammable environment without causing fire or explosives. Uh, Environmental friendly. The operation of pneumatic systems do not produce pollutants. The air release is also produced in special ways. Therefore, pneumatic systems can work in environments that demand high level of cleanness. One example of production lines of is the production line of integrated circuits. Uh, Economical. As pneumatic components are not expensive, the cost of pneumatic systems are quite low. Moreover, as pneumatic systems are very durable, the cost of repair is significantly lower than the other systems. Maintenance. Pneumatic systems require little cleaning due to the pressurizing air, usually forcing any dirt. Noise. Although air compressors can be quite noisy, they are running their silent when off, and the equipment using compressed air to function is usually relatively low in noise. And the last one is convenience. Because pneumatic equipments requires less force and low pressure, they are more convenient. Next slide. Vishesh start.
Limitations of pneumatic systems. Relatively low accuracy. As pneumatic systems are powered by the force provided by compressed air, their operation is subject to the volume of the compressed air. As the volume of air may change when compressed or heated, the supply of air to the system may not be accurate, causing a decrease in the overall accuracy of the system. Low loading. As the cylinders of pneumatic components are not very large, a pneumatic system cannot drive loads that are too heavy. Processing required before use. Compressed air must be processed before use to ensure the absence of water vapor or dust. Otherwise, the moving parts of the pneumatic components may wear out quickly due to friction. When these systems need special pipes, then the cost for installation will be increased. These systems are not upgradable. Uneven moving speed. Next slide. Comparison between pneumatic and hydraulic system. Pneumatic power. The pneumatic system works through air or gas, whereas hydraulic system works through the fluid. Pneumatic power, it generates less power, whereas hydraulic power generates more power. Pneumatic power is very clean process, whereas hydraulic power is not clean. Pneumatic power is simple to operate and easy to maintain, whereas its maintenance and is difficult. Initial and operating cost is low in pneumatic power, whereas in hydraulic power it's high. Simple complexity, excellent reliability. high peak power. Hydraulic power have medium complexity, good reliability, very high peak power, and very less size. Pneumatic power, good position accuracy and has fast speed, whereas hydraulic power, good position accuracy but have low speed. Utilities of this system are power compressor pipes. Hydraulic power utilities of the system are pump, power, pipes, etc. Next slide. Applications. Construction applications. Civil construction requires equipment such as jackhammers and road drills, both of which can be powered through pneumatics, allowing for remote working under about any conditions. Automatic production equipment used in everything from assemblies to gantries. Pneumatic equipment is a common component of the industrialized world of production, providing precise, quick, and safe solutions for all sorts of manufacturing environments. HVAC control. Many industrial settings and large commercial buildings use heating, ventilation, and air conditioning systems to regulate, filter, and heat or cool the air. Pneumatic controls are used to send those signals and control the devices to trigger action. These are used in railway coaches, automobile braking system, wagons, and printing presses. These are used in industrial robots for different purposes like packing, filling, drilling, stamping, punching, hosting, and clamping, etc.
So that was all about our project. Thank you for your time and attention.
Thank you, sir.
Thank you, sir.